All right, today we're starting section 2.5. We are going to be solving compound inequalities and graphing them. A compound inequality is an inequality formed by joining two inequalities with the word and or the word or. So seeing or next to each other might seem a little bit weird, but those are the two words that could possibly join a compound inequality. And inequalities. The graph of an and inequality is the intersection of the graphs of the two inequalities. You can summarize it in your own words, but yes, we need these in our notes. Yep, the whole slide. You can summarize it if you want, but we need all of it. The graph of this and inequality would show the numbers that are solutions of both inequalities at the same time. So anything that's an answer has to work for both of them. Next up we have or inequalities. Again, I would maybe title this section so that way we can shorten down the notes about it. The graph of a compound inequality with or is the union of the graphs of the inequalities. So it means both of them on the same graph. They don't have to intersect. It's called the union of them. The graph is going to show ones that are solution of either inequality. It doesn't have to work for both of them. It just has to work for at least one of them to be on the graph. Okay, this whole intersection versus union will make more sense when we actually show graphs of them. For example, an OR graph is usually going to just look like two problems graphed on the same number line. So it could look something like this. We would just have two graphs and we would see them on the same number line. That's what it means by union. Here we're going to see some steps of solving inequalities with and. Sometimes you won't see the word and written. We'll just have a double inequality. So we'll have two inequality symbols written. So this is example 1. You don't necessarily need to write the steps unless that helps you, but that's going to guide us through this problem. Okay, so the first step is going to be to separate the compound inequality into two inequalities. To do that, the first one, we're going to start at the beginning of it and go until right before we hit the second inequality symbol. And that's going to make one of our inequalities. So -4 is less than x minus 2. That's one of them. To get our other inequality, we're going to start at the back of the problem and do the same thing. So we draw a box and we stop it just before the other inequality symbol. So for this one, we would have x minus 2 is less than 3. Do we have questions about how we split it up into two? Okay, step 2 is to solve both of those. So to solve the first one that I made, what am I going to do to both sides? Add 2 on both sides. That's going to give me -2 is less than x. Flip it over. We want the variable to be on the left. So we get x is greater than -2. Then we have to solve the other one. Again, to solve it, we are going to add 2. This time we get x is less than 5. All right, step 3 is to graph these on one number line. And also we have to keep in mind for and inequalities, we're only interested in where they would intersect. So let's make our number line. Let's see, we need both -2 and 5 on this number line. 0, 1, 2, 3, 4, 5. Okay, if you wanted to count by 2s, you could do that instead. But make sure that you're making your number line so that both of these numbers will fit on it. Now, at both -2 and 5, what kind of circles do we want? Dominic?
They said open.
Open. So those rules still apply. We have open circles because we do not have the equal to bar. It's possible for these to have different circles. So it's possible for one of them to have a bar and the other one to not have a bar. One be closed, one be open. Then we have to look at where we want to shade. So this one says that we are greater than -2. So from -2, we would shade which way? To the right. But we need to stop before that point. And from the 5, it's saying we're less than, so we would shade to the left, but we can't go past this point. So we are only going to be in between. So if I show above with a highlighter, okay, this one would be getting shaded that way. The other one would be getting shaded this way, but we only want where they intersect or overlap each other. So that's just in the middle. So the only place I really am going to shade is in between them. Not through them, not past them. No arrows, just in between. So for and, we want where they overlap or where they intersect. That's usually going to be in between. Questions about our first example? Need more time on it? Okay, take a minute before we move on. We're going to use those same steps to solve this compound inequality. So remember, our first step is to separate it into 2. Can anybody tell me what one of my inequalities is when I break this up? Lydia? Good. Yes, we need the +1 on there. We go all the way up until we hit that second inequality symbol. Good. For the other one, we could start at the back and we go all the way until we hit the other inequality symbol. Okay, so whatever was in the middle is going to be getting used on both of them. Questions about splitting it into 2 problems? Okay, the next part should be the easiest part. The part that we practice the most is solving them. So my one on the left, how am I going to solve it? Subtract 1 on both sides. We get -4 is less than -2x. And then we would divide by -2. We got to be careful here because what happens? The symbol is going to flip. But then we have to do what? Flip the whole thing. Good. Good job. We want the variable to be on the left side. So we got to flip the whole thing over. We use the same steps of subtracting and then dividing to solve our other one. We just have a different number involved. But again, when I divide by a negative, I need to flip the symbol. Do we have questions about solving either of those? Okay. Our number line should include the numbers -4 and +2. So I'm going to count by 2s. Are we open or closed at -4 and 2?
Open for both of them.
Okay, open on both of them. They both had just regular signs without a bar. Now, if we're looking at our inequality that involved 2, from the 2, we would be going which way? Shading. Left. So if it helps, some people like to show that up top. They like to show that this one would go to the left. And from the -4, we would go which way? To the right. So they are going to overlap each other in the middle again. So that's the only place we shade. If you want to show yourself little notes above the bar, that's fine. I'm going to be grading what's actually on your graph. All right, let's try another one. This one, you might notice from the beginning, one of these symbols has a bar, the other does not. That means one of our circles will be filled in and the other one will be open. Do I have any new volunteers to tell me what one of my equations would be? Andrew?
5 is less than or equal to n plus 4.
Very good. James, you have the other one?
N plus 4 is less than 2.
Good. Split it up into 2 problems. To solve both of these, what are we going to have to do? Subtract 4 on both sides. And the one on the left, again, we're going to have to flip it around so that our variable is on the left side. The other one, we don't have to worry about doing that. Okay, the splitting it up and solving, I think, should be pretty easy parts to do. I understand the graphing on these is different, so it can be a little bit tricky. On this one, we just need to see the numbers 1 and 6 on there somewhere, so I'm not worrying about my negatives. If you put negatives on your number line, that's fine. At 1, are we going to be open or closed? Closed. At 6, are we open or closed? Open. Okay, if we were at 1, we would shade which way? To the right. I'll show that. To the right. And if we were at 6, we would shade to the left. So where do they overlap each other? In the middle. That is frequently going to happen. Where on ands, we're shading in the middle. Mm-hmm. So some of the problems, they might give you a graph and you have to decide if it's an and or an or. If they ask you what type of compound inequality it is, this would be an and. But like on a problem like this, I wouldn't expect you to have to write out and anywhere. Anything else we want to talk about before we move on? Okay. Go ahead and try this one on your own. We've done a few together now, and we'll talk about it in a minute. All right, I need to know one of my inequalities that I set up. Lydia? Negative 3 is less than 2k minus 5. Can somebody else give me the other one? Jermila?
2k minus 5 is less than 6.
Very good. We've got two inequalities to solve. On both of them, what's my first step? Add 5 on both sides. And then I would divide by 2. We get 1 is less than k, but we need to switch it around. K is greater than 1. I take the same steps to solve the other one. This time I get k is less than 6. All right, much like our last graph, we need to have 1 and 6 on there. Are we open or closed this time? Open on both of them. Okay, I don't expect you to have to show every time the part above. Did anybody figure out where to shade on this one? It's still in the middle. So we're bigger than 1, but smaller than 6. That's going to be the numbers in between them. Bigger than 1, smaller than 6. Questions about and inequalities before we move on to or? Okay. All right, for solving a compound inequality with or. Again, you don't necessarily need to write these steps, but I would write down example 5 and follow along with how we solve it. This one is a bit more straightforward in my opinion. You will actually see the word or, so that's less work. You don't have to split it up. You're going to solve both of them. You will graph them both on the same number line. We don't have to worry about splitting it up. We don't have to worry about overlaps. It's just like having two problems at the same time. So if we take the first inequality, 3y minus 5 less than negative 8, what would I do to solve? Add 5 on both sides. 3y is less than negative 3, and then we divide by 3. We get y is less than negative 1. On my other inequality, 2y minus 1 is greater than 5. How do I solve? Add 1 on both sides. That gives me 2y is greater than 6, and then we divide by 2. Y is greater than 3. Okay, we've got two solutions. We're going to graph both of them on a number line. We need to make sure our number line has a negative 1 and a 3 on it. 0, 1, 2, 3. So let's start with y is less than negative 1. Open or closed at negative 1? Open, shaded to the left. And I'm going to go ahead and just shade on there right away. We don't have to worry about an overlap this time. When we go to y is greater than 3, are we open or closed? Open again. This time we shade to the right for greater than. So on and inequalities, we will usually see the middle shaded. For or inequalities, we will usually see the outside parts shaded. We just go by the inequalities that we have, but that's a common pattern. And in the middle, or on the outside. Questions on number 5? Okay. Let's work through number 6. Again, it's just like having two problems from yesterday at the same time, or two problems from Monday. If I'm starting off with my left equation, what's my first thing to solve it? Subtract the 3. 4c is less than -8. And then we need to divide by 4. C is less than -2. We solved the other one. What do we need to do? Add 8. This time we get C is greater than 7. We make our number line. We want to include both -2 and 7 on it. I'm going to count by 2s this time. Am I open or closed at -2? Open at -2, shaded to the left because it's less than. Even though ors usually go on the outside, we should still pay attention to what our symbols are telling us. Where is 7 going to go on this graph? Good. Between 6 and 8, open or closed? Shaded to the right because it is a greater than. Questions about the ors? Okay, in my opinion, ors are pretty easy because it's just 2 and 1. It's like a twofer. Buy one problem, get one free. Are we ready to move on? Okay. So on this problem, we are going to practice taking a graph and writing the compound inequality from it. Okay, so I would sketch this graph, if it's a little hard to see, at -3. They have a closed circle and they've got it shaded to the left. At +2, there's an open circle and it's shaded to the right. Now, just looking at the graph for starters, do we think this is an and or an or? Or, good. We're shaded on the outsides, so we could go ahead and write down the word or in the middle. If it's an or, we just need to do each of these separately. So for my one on the left, I'm going to need a variable. What do you want to use? X. If we're shaded to the left, what kind of symbol is it? Less than, but since the whole is colored in, it's or equal to, and my number there is -3. Then we go to the other side. Again, we need to use the same variable, x. This time, which way are we shaded? To the right, so what kind of symbol? Greater than. It is not filled in, so we do not need an equal to bar, and our number is 2. So that's all we needed from that. Got to decide if it's and or an or, and then write the inequality. Do we have questions on this one before we do one more? We got to do one more so we can see what an and graph looks like. We still have at least a couple minutes, if not more. Plenty of time to do this one. At 1, we've got a closed circle. And at 6, we've got an open circle. And we are shaded in between. So if we're shaded in between, is this an and or an or? This is an and. So for and, x is squished in between two less than symbols. So x is in the middle for an and. What number do you think goes on the left? The 1, and on the right? The 6. If we were to take the time to break this apart and flip it around, then it would be easier to see that this would say x is greater than 1. Bigger than 1. It's easy to see already x is less than 6. Questions on this one?
No. Well, could we split it like how?
Yes, if you want to split it and say x is greater than or, oh, I forgot my equal to bar. X is greater than or equal to 1 and use the word and. X is less than 6. You could do that.
Okay.
If you prefer to use the word and instead of putting it in the middle, that's fine. All right, we did have couple more we're not going to get to today. Our homework is on page 85.